Okay, how is everybody this evening? Still boiling inside. What is this? What is this? As I showed in Monopoly 1, this is the size of a corner. And I got the size of the corner by moving this over. There are 1, 2, 3, 4, 5, 6. There are 1, 2, 3, 4. So if it's 6 and this is 4, I would use up half of the next one. But I think I would have to go by sevens in order to get this right. Like I showed in the last one by putting this over 3 properties, right? I put it over 1 property, it shows up here. I put it over twice, it ends up using 3 properties. 2 corners equals 3 properties. And before when I was speaking, I'm not sure if you can see this. See if you can see this. Okay, when I was speaking, this go over here, right? This go over here, when you measure it, it goes 1, 2, 3. So 3 goes equals to 5 properties. So that's the way I have to have it. So what is that calculation? What is that calculation? What is that calculation? I want to do this with you. The calculation, 3 goes equals 5 properties. So you would have to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have to have 5 properties. So if 3 of this would be 15, so this would be 3. 3. Can you see this? 3, 3, 3, 3. Because you see, the Monopoly game apparently is 20 inches by 20 inches, the board. So if it was 20 inches by 20 inches, what would be the value of each of these going across for the 20 inches? Saying that 1 inch is lost to the inside lines or spaces in between. Do you think there's one line? We're not going to count it that way. And the edging on the board, we're not. So what would be the length? It would be, since there's 10 of them, are there 10? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 11. It's 11 wide. 11 properties wide. I'm just going to show you that 2 corners and then 9, 9, 10, 11. So it's 9 on the inside plus the 2 corners, 9, 11. Right? You go to jail. You know what happens? You go to jail? Number 31, the 31st area. Number 31 brings you back here. This one will create the Spirit in the Moon, DC. Here you collect the money. 10, 20, area 21, blackjack. You collect the money. Although it's 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So everything is going to, and the last property to get over here is, what is this, the Mediterranean? And you have to go all the way around the board because you're playing with 2 dice. So we're going to get back over here. So 5, 10, 15, 3, 6, 9, 12, 15. And this is where the railroad would be. So this is the size you would need. It would be a 5 by 5 calculation. So if we have 5 by 5 calculation, I'm going to have 9 times 3 equals 27 plus 10 equals to 37. So the board would be 37 by 37 squares. And let's get the calculator over here. Whoop, got to make sure I don't do the wrong thing here. 37 times 37 equals, there's going to be 1,369 area squares that will occupy and create this board. So I'm going to have to figure out, am I going to end up with a single dot in the center? Will I end up with 9 Well, I end up with 4. There's a big difference. Before in the last video, I was talking about a 4-1-4 exchange. Well, a 4-1-4 exchange means that it's either this or it's this. Anything else is going to be in between. It's either this dot or these 4. If it's these 4, the board is going to be split. If it's this one, everything's going to be split this way. And this center dot will be shared by all. Like in a regular Monopoly board right now, there's 169 area spaces in the smallest board, in the smallest design you can create, and always creating that the corners are twice the size at a minimum towards a property. But the actual real size, according to my measurement, is a 5 by 5. So you have 1,369 or 369, 1, 369. And actually, we don't need the 1, we don't need the 3, and we don't need this. 1 and 6 come together. 9 is all area spaces. 613 laws of the 9 birth. This and this, 7 by 3 is 21. And 10 equals to 31 minus 10 equals to 11. All 10s, I don't know if I showed you this, plus 1, minus 1. So how do you do plus 1 to minus 1? You go down here, and that's your 0 area. So when you see that ace, and bar the ace, because you have to pass down, you cross over from minus 1 to plus 1 and you have a bridge, or you pass down to where the 0 area is and then back up. Plus 1, minus 1, minus 1. So this is just, so then you would see if I would have to draw a line through this, okay, I would draw the line this way, and that would be your Y2K. Is the way I'm going to look at it. So if the board was designed this way, but it's not, we're going to look at this board over here. Is this still Boyd 444? What were we talking about before? This is your 1, 2, 3, 4, 1, 2, 3, 4, 5. This is your 6 by 6. This is your 6 by 6, where 36 is in each corner. So there would be a size of a board, more than one board, maybe not. So this would be 6 by 6, 36, and then you would have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So you'd have 24 equaling to the day. Each property would equal to a day. The trains would be 96, and that would be rotation, because you'd have 4 trains, 24, 24, 24, 24, 96. That would be your rotation. Number of squares per corner, 254. That means in this area over here, there's 252, which would be, when you multiply it, you'd have 10 and 7. That would give you your Q. That would also give you 2 times 5, 2 plus 5 equals to 10 letter J, or the reverse, 7 letter G. And what's funny about this is that the French use the expression of J for a G, or they exchange the sound in it. The total is 17th letter Q. And the Q, okay, pending the language you use, usually comes with the U, unless you're a certain part of the world where they don't use the U at all. There's 22 properties, apparently using up 528 area space, and that would be a certain vibration. 22 properties by 24 each one. 24 each property. There are 22. That would take up your 528. There's a few more pieces in here. If I got that right, there are 324 area spaces per quarter. 1, 2, which is instead of 9, because I have to use half the trains, right? Because there's a total of 9 areas. So you use 4 areas and then half the train, and then 4 areas and half the train. So you would have 4 times 4 is 16, 17, 18. So you'd have 18 by 18, which gives you that 324 vibration over here. And there's 1,008. I don't remember where that 1,008 came in. I'm a little tired, but 4 areas equals to 1296. And 12 and 13 are different because 13 is the male and 12 is the female. And 13, when you have 13 as the male, you already have the 1 inside the 3. And 13 is not like 17, 18, 19 is not like 13. And 12 does not have a teen in it. So that's it. That's it for this video right now. I'm very, very tired. These are properties that I divided up. I was counting something a little bit different, going like that. 4 areas in the corner. Hold on a second. 4 areas when you're running a corner like this. 4, 12, and then 20. I'm not sure what this is going to bring to me. 2012 to 2021, I'm not sure. And then this corner would be flipped out, and and it would come over here, and it would take up this area space. And I'm not sure if this is the pyramid going up, but there's all kinds of different things you can do in this. I'm just extremely tired. It's time for bed. I want to thank you for watching the video. There was one more video that I didn't do. I think that was the 3x3 area space. It was just very interesting the way it calculated. Where did I get that? Did that paper go? It was just the calculation. I don't know. This 1,008 is another calculation. I forget where this comes from. I know what it means. Oh yeah, there's 864, 144 right. There's 36 areas. 4 by 9 is 36 areas. Properties, the 9 properties. Okay, there's 9 properties, and they each take up 4. 9 by 4 is 36 by 4 areas equals to 1,440 or 1,440 minutes in a day. And then there's 864. I forget why 864. Somewhere in the measurement there was 864 that comes up in this. I'm not really sure where it is. I don't remember. I'm too tired. And that would be the seconds in the day. And seconds calculator 216 in another area would be the moon, and that would be 1.5 times the minutes in a day would be the moon area towards the birth. 9 by 24, 9 areas of 24 equals to the moon. So 1 strip of 9, unless we do this. Imagine if we did this here, these 4, 24, 24, 24, right? 3 and then 1, a 24-hour day. And the 1 is split because it goes with the trains. Do you follow what I'm saying? Trains own each side of the properties. So you have 1, 2, 3, 1, 2, 3, 4, 5, 6, 6 by 4, 24, 24, 24, 21, 96. And then here you have 36, 96, and 6, 102, 132, and 96. Let me calculate this. 36 plus 96 plus 96, and the corners would control 22.8. 192 plus 36. Is that right? No. 192 plus 36. Yeah, 228. The cycle, the Venus cycle of the moon. Any questions out there what I'm talking about? Does anybody understand? For the 2 people that are here right now, do you understand where I'm going with this? Everything has to be measured, and there's a certain calculation, and there's a certain story in every measurement. And if we have this measurement, I can probably use both boards. This is the 3 by 3, 2 by 3 area boards, and I can probably match one over the other, right? But it's going to take up a different size. I mean, look at the size difference. This board fits right in the center over here, so there can be multiple levels of boards in between. Anyways, thank you for watching this video. Have a good night. Raphael 7286 in a constellation of Pegasus. Thank you for watching. Say it now. Good night.